Let me know if you all can view my screen.
Yeah, we do.
All right. Let's get started. Hi, everyone. Very good afternoon. Thanks for joining the session on GCP Associate Cloud Engineer Certification Focused Training. And it's me, Bhaskar Manoharan, your instructor for the next 12 sessions. I hold 12 plus years of experience into IT. To be more specific, this February, I'm going to complete 13 years of my IT experience. And I've started my career as an hardware engineer, followed by desktop support, system administration, and so on. And I'm currently serving as a technical training manager in a private firm where I have trained 11,000 professionals globally on virtualization and cloud platform. My areas of expertise resides around VMware, AWS, Azure, Google Cloud, IoT, ethical hacking, Veeam backup and replication. And I am a GCP certified solution architect as well. As part of this program, we would be understanding cloud solution environment. We would be learning from the scratch, like how to set up an account, how to get started with your own subscriptions, how to create an IAM roles and permissions, how to create custom roles, and how to use a default roles, and how to play with multiple infrastructure as a services, platform as a services, and software as a services with the GCP. And then we would be planning and configuring a cloud solution where we would be taking in production use cases, and we would be understanding like a traditional a web server based deployment in an organization will understand which are the prerequisites which need to get started. For an example, networking point of view, storage point of view, security, backup, solutioning in terms of monitoring, alerting, log analysis, root cause analysis, and so on. And then we're moving on to deploying and implementing solution where we would be deploying a virtual machines, building up load balancers, building up auto scaling environments, building up peering between two different VPCs, setting up a database where you would be deploying under a compute engine, and additionally we would be deploying database as a service to connect to our front end web servers. And then we'd be moving towards successful operation of cloud solution, which involves managing and high availability to achieve 99.9% and above uptime on a production environment. And then moving on to access and security, where would be enabling multiple firewalls in terms of virtual machine level, in terms of subnet, in terms of an application. So you would be enabling WAF web application firewalls and enabling cloud armor to protect against external DDoS and cross-site scripting attacks. Yeah, so it's all together. We would be following the official content, that is GCP Associate Cloud Engineer content, so that it covers everything. Anything you see on a traditional GCP setup, all are included in this. Yeah, and total duration is 36 hours, out of which you would be having a dedicated 33 hours for this program, and 3 hours I have kept it for exam preparation as well. So that if you are willing to take up a certification post this training, you are good to take up this certification as well. And additionally, I would be bringing up at least 300 plus GCP Associate Cloud Engineer sample exam questions, and we will also be discussing a scenario based questions on the last day, so that you will understand what kind of questions can be expected on an exam. And also you can keep yourself so that you can keep yourself prepared for this session, prepared for the examination, as well as it will help you to prepare for your interview or whatever it is. So ultimately this training will give you a knowledge on the whole. All right, hope you all can hear me.
Yes, Bhaskar.
Yeah. All right. Yeah, so I would like to set the expectation on day one, and that's why I'm be more specific on it. And additionally, I would like to share all of you this content. I request you to open this URL.
Okay.
I'm following the official content so that you will have a clue. As we progress, you will have a quick check on the progresses. All right. Yeah. So now I also would like you to introduce yourself, and I'll take your expectation from this training. If you feel anything, would like to add up anything, remove anything from this content, or you want to be specific on some modules, I'm happy to organize as you requested. So kindly get started. So for this, let me request from the order. Amit, would you like to introduce? Yeah.
Hey, yeah. I'm Amit, है ना? So I do manage this the entire portfolio, rental
Okay.
portfolio. Okay,
Uh-huh.
and under me, Wintel, VMware, Citrix, messaging, all means teams used to report me. So
Mm-hmm.
I also being excited to be a part of this training, so that we all will be on the same page, and we can just give our best to the clients, because I think beginning of this, maybe Ranjit might be discussed with you that why we have been looking for this training is because client is being planning to be moved from this the on premises to the cloud very soon,
Sure.
and they have been chosen the Google Cloud.
Mm-hmm.
So we are being just means in the beginning stage, you know, means if you know that,
Mm-hmm.
because see, theoretically we may have gone through the multiple docs whatever is available, but
Mm-hmm.
we here means our expectation is if you can give some kind of the live examples, or if you can give the more hands on, so that we
Mm-hmm.
can feel comfortable to when we'll start managing the client's environment.
Absolutely. Yeah. Amit would like to set the expectation here, and I'm a person who works on GCP on day in day out. Okay, I can bring up a production scenarios, and as I mentioned, so you will have a project itself altogether. I want everyone to
Oh,
work on a,
great.
yeah, I want you to work on a project itself where I would be bringing up a scenario. Okay, to be more specific, I can show you the project which I have recently worked for the student. So I'll just show you this project, because the one which I did that is official. I cannot share that, but I can show you a close by project. So kindly have a look into this. So each students would be working on services like this. They would be designing a solution like this. Okay. And there will be a service flow briefing, and then they have to provide step-by-step procedures like how it's gonna work, how it's gonna interconnect, like front end, back end, and so on. Right.
Yeah.
And also additional support and operation supports like cost optimization and other thing. You see, it's a proper project. This is a demo version, but I have an extended version which I did for my production environment. So this is a clue that what you would be doing. Okay.
No, that is great. Means if we will have these kind of the sessions,
Yeah.
so definitely it will give some kind of the sense how to be just handle the client's environment, because here
Yeah.
if you see the entire batch is just moving from this setup to this different client's cloud environment and all.
Mm-hmm.
So it will be good, you know, if you can just, as you said, we
Not
are
an
being very
issue.
excited. Yeah, yeah.
Not an issue. I'm happy to support. Not an issue.
Okay.
All right.
Thank you.
Thanks, Amit. Thanks for sharing your inputs, like more hands-on. If you ask me, I would like to tag like this: 80% practicals and 20% theory. All right. Mostly would be doing a practical. I'll ask you to do a lab. Okay.
Good. Yeah.
Right.
Thanks. Thank you.
Right. Let's move on to other participants. If you are in A order, kindly follow. I have to switch between the participants list. So I think second one is Appu.
Well, hi Bhaskar, it's Ranjit.
in fact, because looks like I think it has taken up my Gmail account and it is showing you as Apu there.
Okay, Ranjit.
Anyway,
All right.
so in terms of my work, I report to Amit. So Amit is our portfolio directors, and I report to him. So in terms of expectation, it would remain the same, like Amit was saying before, right? So currently we are all working in a same team. In fact, okay, we are supporting the non-premises infra, where the majority of the members on this training are supporting for Windows and VMware, right? So it could be on hyper-converged or converged infra. But in terms of the cloud, theoretically, yes, we do have some information or we do have some overview. But in terms of hands-on or in terms of how it works, yeah, so that we would be requiring, or that is expectation, which I would say from your side. And in terms of exposure, yes, we would like to get more and more into the lab exposure, because theoretical part we can go through some recorded videos, or we can go through some docs. But in terms
I
of
understand.
labs and hands-on, right? So where we would need more in detail session, in fact. Okay.
No
And
problem.
see, yeah. And second thing is that in this training, please don't mind. There could be some stupid questions also can come out, right? Because
Not an
for
issue.
everybody it is a new, for everybody it is a new thing, and we are all learning in alphabets, not in framing the sentence or framing the words, right? So we might have heard about the terms, but really we are not quite used to that in terms of Terraform, or in terms of regular cloud terminologies, whatever we are using, whatever the services which is offered by Google. So you can expect some dumb question, you can expect some stupid question, but again, that is for clarity for our side.
No problem, Ranjit. And being a proper Windows VMware guy, I'm from VMware itself. I worked for VMware close to 3 years before joining current organization. I was a full-time employee, and I do have my own data center set up on VMware itself. So you can feel that it's like I'm one of your internal colleague who trained and who is already in GCP practice, who helped to assist your team. You think more like a knowledge transfer. Okay.
Absolutely,
I'm happy to support.
Bhaskar. Yeah, and other thing which I would like to stress here more is, in the future part, right? In most probably in the month of January, so we might get an exposure to work directly on the migration part, right?
Agreed.
So on premises to the GCP. So I want my team, to go through the each steps and what are all the things which has to be followed for easy migration, and then the post implementation support.
Sure.
So that is the two things which I'm keenly looking out from this course, Bhaskar.
Sure, no problem. I'll keep a dedicated sessions on migration where I would be discussing about on-prem Hyper-V or a virtual machine migration to GCP using Velostrata, and additionally, I'd be discussing about application migration best practices, database migration best practices, data migration best practices. Okay.
All right. Yeah.
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 Moving on.
Thank you.
Yeah. Thanks, Ranjit. Moving on. Other participant. Deepak.
Hi Bhaskar, Deepak here. Yeah,
Yes,
I'm from
Deepak.
VMware team. I'm reporting to Ranjit. So my expectation remains the same, like as Ranjit and Amit said, like we are completely new to this technology, and and more hands-on experience, as well as like practical sessions. We need more than theory. So because theory, every session we can't keep remembering things. Like if we have a hands-on experience, then it will be good to remember.
No problem. No problem. As I agreed with Neel, this session it's gonna be mostly on the practical, and that's why I'm keeping track of all the requirements here. And you will get like 80% practicals and 20% theory. So I'm assuring you this. Okay.
Sure. Thanks, Bhaskar.
Right. Moving on to Sarathi.
Hey, I Bhaskar, Sarathi Rajendran here. I have plus years of experience in the IT industry.
Yes.
Our expectation is same actually. See, we all are actually part of one team, and we are actually trying to learn cloud. We are new to cloud. We don't know anything cloud. We never had any experience on the cloud technology.
Okay. So
we
that's fine.
go
So I'm happy to mark your expectation as Ranjit and Deepak has set for the entire team.
Yeah,
correct, Bhaskar, Radish here. So in fact, Yeah, in
Okay.
fact, Amit and Ranjit, now the Saradi,
Mhm.
all are echoing the same way, right? Let's
Mhm.
move on with the course because we are having the same expectation, in fact.
Sure,
Okay,
sure,
so, yeah, I think,
sure.
yeah.
I'm happy. I'm happy. So, anybody, anything would like to add up, or anything you need in specific? Please let me know. I'm happy to keep a track here, because usually I follow a standard. Like on day one, I would like to set up an expectation so that the same level of expectation would be carried out throughout the training, right? So that's why I'm making sure that we are all on the same page. All right. Yeah.
Hi,
Thank
Bhaskar.
you.
Hello.
Yeah. So let's move
Bhaskar,
on then.
Manjunath here. Hello.
Yeah. Yes, please.
Bhaskar, yeah, as it said, on the migration tool, right?
Mm-hmm.
So if we get a training on strata zone, that would be great.
You will not get an hands-on, because
I mean, yeah.
you will get a best practices. Like I have a best practice documentations, like how you can subscribe to Velostrata and how you deploy an Velostrata manager, how it integrates with an agent, and how you can move from on-prem to cloud, and how broker services interconnects, which networking methodology you want to use, whether you're going to use over internet or a VPN. Those things would be discussed. If you see this training, we don't have a migration to be specific. Like the content whatever I have shared, there is no migration, but still I can do a migration part. Other than VM migration, we can discuss about DB migration. We can do a live DB migration, and we can do live data migration and an app migration. But Velostrata, that is compute engine, is not possible.
Yeah, sure. Okay. But instead
Yeah.
of Illustrator, if we get a strata zone, if the tool.
Strata zone, it's for analysis, right?
Yeah.
Yeah, it's
That is
analysis.
what.
Yeah, I can bring about, see, I'll just, what I'll do is, at the time of migration, I'll bring up all the tools we have for individual analysis and migrations. Okay, we'll discuss
Okay.
in detail. Yeah,
Okay.
but kindly make a note, we cannot do all migrations, but maximum what I could share over the years which I have gained, that would be shared to you. Okay, because we have a huge topics. If you look into these modules, like multiple sections, like we have till 5.3 as part of this modules. This required a lot of time, because we have 15 people, right? So I need to have an hand holding. That's why they kept a dedicated topic called GCP professional. That takes altogether a different set of time, where it involves advanced topics. Since you're all from VMware and Windows background, I would like to get started with an associate program, so that you'll have a safe handholding and you can understand this topic easily. Later, once you put on production, then gradually you will gain those knowledges. All right.
Yeah.
Yes, Bhaskar.
Yeah. Yeah. All right.
Yeah, Bhaskar.
All right. Okay, let's get started. So to understand cloud, first we need to understand the infrastructure. So as you know, we have a traditional data center. This data center is set up with networking devices, storage servers, firewalls. So it's all within an organization. Let's take for an example, IBM is an organization who owns all this. Okay, and who can access these resources? They are all internal employees. If you are service based company, in that case, some extent they can also be accessed using external clients. The difference between the cloud and on-prem infra is the owner changes. IBM is the owner who will take the responsibility of investing on hardware. We call it as capex. Who take the responsibility of opex. operational expenses. We'll take the responsibility of licensing, security, availability, DR solutions, backup, right? Whereas in cloud, you will see exactly the same hardware available, exactly the same hardware, but this is owned by a public cloud vendor. For an example, Google, where you as an individual user will act like a subscriber. And the infra is owned by Google. And within this cloud infra, so we'll have anything you do in a traditional on-premises environment where we'll set up an infrastructure services, platform services, and software services. We'll discuss individually what you mean by IaaS, PaaS, and SaaS. As a one-liner, if anyone would like to understand cloud, cloud is nothing but the same physical infrastructure which you managed in your environment, but this is not owned by you or your organization. You act like a subscriber, and you will subscribe for a specific duration that ranges from minimum of 1 minute and maximum of 30 days in terms of on demand, and in case of reserved, it can go from 1 year to 3 years. We have different plans. We're going to discuss about them in detail. Yeah. So anything you do on a traditional infra, you can do again on cloud, and you will be acting like a subscriber, and these resources would be accessed over a browser or an web app or a browser or an application that you install on your phone. So I'd like to call cloud like this: accessing or controlling computing resources through internet over browser or an app with pay-as-you-go subscription. Since this resource is governed by or owned by Google, you act like a subscriber, and based on your subscription plan, you will pay for them. Okay. So that's why I streamline like this. Accessing, in some of the situations where you will more act like in viewing the content, where you do not have a complete control. In some of the services where you have a complete control, like modify, you'll become an owner, then it is called control. A resource which is available in a Google Cloud environment where you act like an accessor or you can act like an owner, okay, and you will access it over internet through a browser or an app with the pay-as-you-go subscription. All right. So anybody, any question on understanding cloud?
So
mainly it is
Bhaskar,
like
in terms of
limitation. Sorry, Ranjit.
yeah,
Go ahead.
go ahead, guys. No, go
So
ahead.
the main motive of this is like limiting the hardware resource, right?
Yeah.
Okay.
Yes. So I'm going to discuss that in detail. Yes. So where you will have an investment year by year and the licensing. So I'm going to bring up in characteristics and advantages. Possibly we'll see in detail. Okay. Moving on.
Yeah, Bhaskar, sorry,
Yes, please.
sorry to cut you there. So going back to the previous slide or your
Mhm.
previous explanation. So in fact, when we are subscribing the services, right? So we will not have a visibility anything on the hardware, if I'm not wrong.
You're absolutely right. It's removes an bare metal layer. See, in VMware, what you used to do, we used to set up an ESXi will install directly on a hardware where we had a control over the hardware resources. Over SIM, common information model, we used to look into the individual components where we logically used to set up multiple CPUs, RAM, and so on, correct? But here,
Correct.
you will not have a direct bare metal access. you do have a service called reserved in, you do have a option, we call it as sole only tenant. So we do have an option, but it is too expensive. If you ask me, people who subscribe on physical hardware in cloud, the percentage is lesser than 1%.
Okay.
Yeah.
So on what cases they will go for a physical subscription, Bhaskar?
Yeah, where you feel security is the key criteria in your organization. As you know, we built cloud resources on top of virtualization, which means the resources being distributed again. Okay, a single hardware being shared to multiple subscribers, where everyone will have a logical boundary where they cannot view other virtual machines, right? So anyone who feels like I don't want to be in a shared environment where my applications requires a direct installation of hardware, and my client feels that is environment to be completely secured from an external shared resource, in that case an organization can adopt to sole tenancy. That is called fixing or dedicating an hardware. All right.
Okay. So since we as a subscriber, we don't have a visibility on what is underlying hardware or what is the software running on the bare metal.
Absolutely
right?
not.
So out of my curiosity, right? So which version or what kind of hardware usually they use it?
Okay. To be more specific, Google builds their own servers.
Okay.
There is no there is no a general version of hardware that they deploy in their environment. They manufacture a motherboard, they'll buy chips from Intel and AMD. Okay, they assemble, they have their own assembly unit, they stack the servers, and most of the things are their own. I would say that more than 80% of the components are inbuilt, and remaining 20% they will have a series, they'll tie up with Intel and AMD. And to be specific, these processor series are dedicatedly designed and delivered for Google. They'll again, this processors would not be available externally.
Okay.
You would have heard about kernel module integrity and all, right?
Yeah.
KMI, kernel module integrity. So where we'll have a protection at the individual motherboard level, processor level, memory, virtual memory level. So we have all those protections are enabled by default in Google environment, where end user would never ever know which motherboard they use, which model of server they use. The only thing they get to know is which processor type they use. Example, Merom. We have different Sandy Bridge, Ivy Bridge, Navy Bridge, right? So we have different Intel processor versions, right?
Oh yes, Bhaskar.
Yeah, so you will get to know only the processor versions which is used by cloud. That's all. I mean, used by Google. You'll never ever get to know which hardware they use, and there
In
is
case
no.
if there is any issue occurs on this servers, like something goes wrong, like so who will be taking care of that? Is the physical subscriber will check on those things, or like how?
Yeah, it's on the
Is there a
pipeline.
separate okay.
You got to wait to me. You got to wait for
Okay.
me, and it's on the pipeline. I'll explain to you. Okay. Yeah, I'm happy to take your questions. If anything that I'm expecting in the future slides, I may halt it there so that I can explain together. All right. Yeah, moving on. Characteristics of cloud. Cloud resources can be accessed on demand, which means you can access any place, anytime, anywhere. As long as you have a valid subscription, you're good to use. This is more like Amazon Prime or Netflix subscriptions which you have in your phone. You can access it anywhere. Point number 2, broad network access. If you ask me, Google has spread over at least 28 regions in the world. So I would like to bring up GCP global infrastructure. So that we can understand in detail. Kindly have a look into this. "28 regions, 85 zones, 146 edge locations, and available in 200 plus countries." Let me brief what is this regions and zones. As you know, Google into the industry like over close to 2 decades, yeah, 2+ decades, and they have started expanding their presence across the globe. At present, they are at 28 states or cities with major data centers dedicatedly for GCP. So what do you mean by state or city? In US, we call it as a state. For an example, South Carolina. In city, you can call it as like in India, we have is in Delhi, Mumbai, okay. So you have city or a state-based deployment, and within this individual city or a state, you will have minimum 2+ data centers. So we call it as DC1, DC2, DC3. So
Zones.
here a region is called a state or a city, and a data center is called zone. Okay, why they need multiple data centers within the same city? The reason is DR, disaster recovery. As part of the DR, they want to make sure that there will be a redundant path is available for those resources in case of one of the data center is interrupted due to natural calamity or network issue or any kind of power issue or an hardware failure. In that case, the other data center would act like a recovery site. So in SRM, we have something called protected site and recovery site, right? So where this will act like a recovery site. And this is protected site. Right. So we'll see where all we have. So here in India, you can see there are 2 data centers. You can see Mumbai and Delhi. Delhi is the one which they have set up very recently. And you see current region with the 3 zones, future region with 3 zones. So soon you can see multiple data centers, regions with multiple data centers would be set up across South America, North America, and Europe, and one in Asia, Doha. You can see this here. All right. Yeah. Product availability. Yeah. So since 28 regions are active, but it is not necessary that all regions would be provided with all 150 plus services. If you ask me, in Google, we have 150 plus services. So all this 150 plus services would not be available in all regions, because some of them have logistic challenges, or some of the regions, the client expectations are the Google user community would be more focused on the software as a services rather platform as a services. So in that case, based on their analysis, they would have enabled limited services, and as the demand grows, they would be enabling additional services. For an example, kindly have a look into this. Cloud functions is not available in Oregon. Can you see this? Here is the product or a service. This is not available. And when I check it in Asia specific, you see Delhi. I told you, right? Just now they have set up like close to 2-3 months. See, App Engine itself is not available. They will enable one by one as the demand grows. right? Yeah. So broad
So
network
in
access.
India, means how many means clients are being running on this the Google Cloud?
Can you repeat your question again?
No, 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 I'm saying means in India or Asia Pacific region means how many client is already moved to the Google or been using that services.
So they will not have an exact client count.
Okay, okay.
Yeah, you may not, I mean, you will not get it, but unless and until they release documentation stating who their clients are, and even some of the pages they'll reveal few clients, they may not reveal all clients. But I would say that I'll put one liner to that. Okay, so above 9% of the global customers are running on Google Cloud. Is that fine?
Okay.
Bhaskar, I don't see any data centers in China, which means so companies in China they don't use Google Cloud.
They use their own cloud, Alibaba.
Okay.
90% of
Okay.
the local companies are dependent on Chinese data center, Alibaba Cloud.
Oh,
And you see, very close to China is we have one in Hong Kong.
Hong Kong, yeah,
Okay,
I saw that.
if you see me, if you see this, you know, China says Hong Kong is part of China. So, so if anyone is would like to use, they may use Hong Kong one.
Hmm.
Yeah.
Hong Kong, Taiwan.
Hmm. And you know this, right? There is a rivalry between China and US since long. So Google is a US based company. They don't want to take a risk like moving the companies in China. There are a lot of political and other scenarios, sir. Okay.
Hmm.
No,
Okay.
actually, I'm seeing here their more presence is in North America at this time rather than in Asia Pacific. Is it?
Yeah, definitely yes,
Yeah.
because um, that's an origin, right? So that's why they have set up there. US, their preference to US only. Most of the clients are from US. All right. Moving on, resource pooling. Yeah, we all know what you mean by DRS in VMware. So we'll have a logical resource from a physical server. So same thing here. If you would like to dynamically increase the virtual machine size, for an example, I have a Delhi zone. Within this, I'd be setting up a VM. Okay, currently this machine is provisioned from one of the physical server, but in turn this would have been created in the form of an cluster. So let's check this physical server is capable of holding 256 GB of RAM. Let's take, I need a machine which I would like to dynamically expand it to 768 GB of RAM. Okay, in that case, multiple service physical servers are logically pooled and then assigned to a single machine. One is server perspective, the other one is we call it as scaling. Resource can be scaled. So where I would like to increase my virtual machine within a single machine, or if I would like to build multiple virtual machines on multiple physical servers. So one is called vertical scaling, another one is called horizontal scaling. I'll explain what you mean by vertical and horizontal now. Let's take an example. IBM is an organization who initially started with one machine. Okay, so they need a machine. So they hosted all their applications. Currently, it is acting like their web server. And they initially launched a website. At that time, the number of users were accessing this website were 100 users. And over the years, this website gained the popularity, and now more than 10 lakh users are trying to access this website. In that case, me as an individual solution architect, I won't design a solution like all 10 lakh users would be hitting a single web server. In that case, I have to scale. I have two options. One is increase the capability of this machine like 768 GB of RAM, okay, where I scale within a single machine. This is called vertical scaling. Okay, scaling up and down, we call it as scale up or scale down based on the requirement in one single virtual machine. This is called vertical scaling. This is one option. The other one is I don't want to hit it to a single machine. I want to enable a load balancer so that the request can be distributed across multiple virtual machines. So this is the best practice. Like it should be hit to multiple machines so that one machine no need to take all loads. Okay. Yeah. So when I deploy multiple machines like this, VM1, VM2, VM3, VM4. So ultimately how much I need? 768, right? I'll keep 200 GB of RAM in this, 200 GB of RAM, 200 GB of RAM, 200 GB of RAM. So I have split it to multiple machines now. Okay, and all are distributed, and whenever the load comes from an external resource, it will get distributed over a load balancer to multiple machines. In that case, I am scaling out. This is called horizontal scaling.
So if it's in a cluster, it's called like horizontal, right? So
Yeah.
we also have few servers which is not part of any clusters, like standalone. So those are vertical scaling.
Yeah, so anything which you are not expanding it other than the single machine, then it is called vertical scaling. And if you are expanding the multiple machine which spread across multiple individual physical servers, then it is called horizontal scaling. All right,
It is auto scaling, right? Pastor, you
can you
mean to
repeat
say
again?
that is auto scaling, right?
Yeah, auto scaling.
Hello?
Yeah. Yes,
Auto scaling option.
absolutely. Yeah, auto scaling. Yes,
Okay. Okay.
we have a lab also. We're gonna discuss about instance group, and we have a practical lab. We're gonna see how exactly a single rule or a condition which I set within an instance group would spread multiple individual virtual machines across data centers or zones. All right, we'll discuss about this. We have a dedicated lab on this. So hope you're understanding the scaling concept, right? All of you,
Okay.
please confirm. Yeah, scaling comes under rapid elasticity.
I have a question here.
Yeah, go ahead.
I wanted to start up a company, okay, small company. I'm planning to go to cloud because I cannot afford to set up my own infrastructure, okay.
Correct, correct.
I have a requirement of deploying some 50 to 100 VMs, and I see, okay, when I plan to go to GCP has data center only in Mumbai and Delhi, okay.
Correct.
So my requirement is actually to have 50 to 100 VMs. Where those VMs actually will be deployed? Will be deployed in the Mumbai data center or Delhi data center?
Good question. You as a customer, you have a provision to choose which data center you want to deploy. You can select.
Yeah. Okay.
That again depends upon the user where they are trying to access, right, Bhaskar? Is it?
Yes, you're right.
Now,
So,
okay. If I plan to go with the Mumbai data center, okay, if I deploy all the VMs in the Mumbai data center, okay, in case if the Mumbai complete region is down due to any due to weather or any tsunami or whatever it is, so my application will be down, right? So in those cases,
no. So that's why we have 3 zones by default set up by GCP, right? You would be deploying on one zone and your resource gets replicated by default. Google Cloud is giving an SLA to you, 99 point.
Yeah, I understood. I understood with region and zone. Okay. My concern is actually if the entire region is down due to natural disaster. Because see, I have decided Bangalore is, see, I'm sitting in Bangalore. I see compared to Delhi, Mumbai is near to me. So I thought of the Mumbai data center. I have deployed all the VMs in the Mumbai data center. Okay. So after some time, actually due to natural disaster, okay, Mumbai is completely down. One region is completely down.
Then I will never ever deploy my resources if I feel like my applications have one single point. In that case, I will never ever design a solution to keep everything in Mumbai. In that case, as part of my design, I will deploy Mumbai and Delhi.
Delhi, okay.
Yeah.
So, okay, so this actually vendor will suggest or it's customer who is the one has to decide on this?
It's, if you ask me, if you are a solution architect, you have to take a call. You have to design a solution for them.
Okay.
So in that case, Bhaskar, in case like in whatever the services that are available in Mumbai, if it's not available in Delhi, like you said, right, on like all the service will not be available in all the zones and regions.
Correct.
So in that case, what we can do, like now, whatever Sarthi said, right, like if we have to deploy in Delhi also, but whatever Mumbai has those services which is not in Delhi. So in those scenarios, what we can do?
Let me put it in this way. See, Delhi just 2 months old setup. Okay. If you ask me, the nearest one to me again is Hong Kong or Singapore. Okay, I'll deploy it there. And the other point is cost saving or cost optimization. Okay, so what I'll do, I do have alternate solutions. It depends on what service you deploy, right? So let's take an example. I want an serverless computing where I want to build a code and then execute directly on a cloud environment. I don't want a compute engine or a PaaS service. I don't have a compute engine, but I need a PaaS service, right? In that case, App Engine is available across the globe. And if you ask me if one of the region is not, one of the zone it is not available, or an data center it is not available, I'll choose the nearest zone until that service is available on that zone. Okay. Yeah. And moreover, my client also matters. I'll finish off this one moment. Moreover, the client also matters. I'll look into the traffic. I'll have an analysis. I'll have an BigQuery analysis. I'll have an reporting system which helps me to understand where is my clients are requested from mostly. For an example, if they are requesting from US location, in that case, I need to deploy an alternate or an edge location for my applications. And if I see that it is coming from Europe, in that case, I need to set up one more edge location there. So it's again, it depends on what kind of application I have to choose. So you Google Cloud never says that I'll not support all the services. Currently, the service is not available in this zone. I'm setting it up for you, but you need to wait. Okay. And alternatively, you can choose the nearest zone. That's the best option.
So when we move to the nearest zone, is that do we have any sort of latency or?
See, we are in networking world. As you know, the latency between one country to another country definitely will vary. If you ask me, the least latency you can expect from an GCP location is lesser than 10 seconds. Okay. And I think I'm not sure whether you were there on the first day of there was a demo session, and I have explained about the latency and other things. Definitely there will be a latency, but it won't be like more than 10 seconds. It will be lesser than 10 seconds. And Google data centers are designed like this. And if you want to enable an optimizations like content delivery and all, we have additional services like CDN. You can enable or optimize your content delivery again. Hope I answered your questions. Do you have anything to raise?
Anything?
Anybody, any question? Anybody?
No, I'm good. Huh? We're good, so you can. Any
Bhaskar,
questions for anyone?
Yeah,
I'm
Bhaskar,
just checking.
actually, see, yeah, Radish here. So by default, suppose we select a platform or service, I think definitely that there will be hosted in multiple zones, right?
Yeah.
Yeah, so that is like there is no additional cost, but if you select multiple region, there is additional cost involved, right?
See, the cost of individual services will vary from country to country. Okay, if you ask me, US is the cheapest location when compared to India again. Cost will vary. That is true. You have to design a solution. You can tell, like, you see, for your client, you have to design a solution. Anyhow, there will be a discussion on how much it would cost. You're gonna give them an estimations, right? It's a client is the one who is gonna take on a call. Okay, go ahead. So you are here to give a solution in a more optimized way, which involves availability, scalability, security, compute, storage, networking, and everything, so that client will take a final call. Yes, you can go and deploy it. You can tell them clearly, see, this is what is available as of now, and this is what gonna happen. And if you'd like to enable a solution, plan A, plan B, if you want to go with this plan, this is what will happen. If you go to plan B, this is what will happen. So client has to compromise. If there is no services available from that specific zone, that's the only options, right?
Right.
Yeah. And in that case, if you dedicatedly want to use and optimize it, in that case, you go for an hybrid infrastructure where you build between two cloud vendors, like you choose between AWS and Google Cloud.
Okay.
Yeah. So we have
Sorry,
solution
Bhaskar,
for all. Yeah.
Yeah, coming back to Sarathi's question, as we were discussing about deploying an image or deploying the project in Delhi, or sorry, in Mumbai, right? So during the disaster time, so is it something that, like, the replication of the, data will get replicated to the other available zone that is in Delhi?
Yes, that's what the commitment for you from GCP by default. And additionally, if you feel you want to enable your own, see, apart from GCP, you are concerned more about the availability of services. GCP also provides optimized services options where you enable one more layer of protection by deploying in within an across the zones, and by enabling performances in terms of CDN and so on. So by default, you have an SLA, example 99.95%. And additionally, if you would like to enable 99.99%, in that case, we have an alternate solution also. Okay, zone redundant replications, region redundant replications, cross zone replications. So rather multiple options are available. Okay, it depends on like what service you choose, whether you choosing a data service or a database service, an application service, or an infra service. This deployment would vary.
So that means by default, when I subscribe any services, right? Let's say, for example, I'm deploying any virtual machine with some application hosted. So by default, you don't get the subscription for enabling the replication between the other zone, or it has already been enabled with the same subscription charge.
That is what we're gonna do. We have a lab on load balancer and auto scaling. You will learn in detail. Okay.
Okay.
Yeah, if you ask me, we have solution for all. It is already set up there. It's for us what we have to choose. Okay, we'll discuss that in detail. We have a topic called instance group. We'll learn a lot. Is that fine?
Yeah.
Okay, moving on to advantages of cloud. Yeah, we discussed already, like you would not be a single owner where you need to invest everything from scratch. Rather, you would act like a subscriber and you would end up in paying a rent for every month. Example, if you have used compute engine, that is virtual machine, for a period of 30 days, by end of the month, you will be paying that bill. Similarly, we have centralized management. For an example, see, in our traditional data center, if you are from a VMware support background, for VMware management, we have vCenter, one console, and we have a storage. For an example, if you are provisioning an iSCSI or an FCLAN, in that case, we have VNX, Clarion, VNX, any kind of EMC storages. And again, if you are in storage, we have file level storage like Celery. We have a different interface. Again, if you want to enable security, network, we have different interfaces. On the whole, we have 5 different interfaces or consoles to manage individual services. Here in GCP, we have one console. For an example, console.cloud.google.com. Have a look into this. You have all services here. Example, if you want to set up a network VPC, external IP, firewall, router, shared VPC, serverless VPC access, storage, compute engine for virtual machine deployment, and then we have serverless computing, databases, operations, IoT. You see all the services here. It's all one single console. You can access all services from this hamburger home page. Here you can control everything. All right. That is all about centralized management. Secured and faster access. Yeah. If you ask me, Google data centers are set up with 1 petabytes per second. They work like internally, they transact with 1 petabyte, and Google data centers are highly secured. And yeah, as I mentioned, they'll build their own hardwares, and they have at least 4 layers of security starting from physical layer. I mean, if you would like to enter to the Google data centers, physically it is protected by a security. Then entering into the building, at the gate, there is one more security. Entering into a lift, there is one security. Entering into a data center floor, one security. And accessing a specific server, there is a security. So at least we have 4+ layers. I would say that 5 layers of security is available from Google Cloud. Okay. So I would like to play like 2 to 5 minutes video where we understand about GCP data center walkthrough and security. So just a minute. I want you to listen to this. Are you able to hear sound? Anyone?
No, not yet.
Not yet. Okay,
No,
one
Bhaskar.
moment. One moment. Let me share that. I want you to, I'm going to put some questions, so kindly pay attention to this video. One moment, I need to enable voice. So this is like around 8 minutes video. I want you to look into this. Hope it is audible now.
Yeah.
Please watch the video.
Hi, my name is Sandeep, a developer advocate on the Google Cloud platform. Welcome to the Google Data Center at the Dalles, Oregon. Take a look around. Before we go inside, we need to make sure that we have the appropriate security clearance. Most Google employees can't even get in here. So let's go on a special behind-the-scenes tour. I'm here with Noah from the Site Reliability Engineering team. Noah, can you tell us a little bit more about the SRE role at Google?
Yeah, SREs write and maintain the software systems designed to keep our services running.
So what happens if one of these systems goes down?
We've designed our systems from the ground up to be able to handle any unexpected failures that might occur. We have highly redundant power, networking, and serving domains, so that even if we do lose an entire cluster, we're able to redirect those workloads and live migrate data in order to minimize any impact. In addition, we have a team of SREs on call 24/7 that can tackle any problems that might arise.
Thanks, Noah. So now we learned more about the systems that manage our fleet at Google. Let's take a deeper look at the data center infrastructure itself. Welcome inside. Before we can continue further, we need to go through the biometric iris scan and circle lock. These only allow one person in at a time and require dual authentication to continue further. I'll see you on the other side. Welcome to the data center floor. As you can tell, we have a lot of servers, and this is a single cluster in a single floor in a single building. Managing all.
So listen to this word. It's mentioning a single cluster. You can see this here.
Floor. As you can tell, we have a lot of servers, and this is a single cluster in a single floor in a single building. Managing all of these servers on a global scale is quite a challenge. To utilize our fleet, we use tools such as Borg, Colossus, and Spanner. You may be familiar with similar tools such as Kubernetes, Google Cloud Storage, and BigQuery. Now, these tools allow Google engineers and cloud customers to more easily manage infrastructure, allowing everyone to build innovative and scalable applications. Here at Google, a lot of our infrastructure is custom-made. This gives us the flexibility and performance we need to run all of our services at scale. Oh, hey, it's Virginia, one of our network engineers.
Hey, Sandy.
Virginia, what are you working on today?
Today I'm working with hardware ops to expand this data center network to deploy additional machines in this building. Our fleet is constantly growing to support new capacity for Google products and our cloud customers.
That sounds like a lot of work to be constantly adding capacity around the globe.
Well, we've designed our network so that this kind of capacity growth isn't very hard. Jupyter, our current data center network technology, is a hierarchical design using software-defined networking principles. So just like with our servers, we've abstracted away the specific details of our network and can manage them like they're software programs and data.
Abstracting seems to be a common theme here at Google. I've also noticed a lot of fiber running in our data centers.
That's right. A single building can support 75,000 machines and carry over 1 petabit per second of bandwidth, which is actually...
Here you can see she used the data transfer which happens within a data center building.
5,000 machines and carry over 1 petabit per second of bandwidth, which is actually more than on the entire internet.
Wow.
This allows us to reliably access storage and compute resources with low latency and high throughput.
So how is this data center connected to all our other data centers around the globe?
Google runs V4, our own private, highly efficient backbone network, which is actually growing faster than our internet-facing network. It connects all our data centers together and allows services to efficiently access resources in any location.
Nice. I finally know what all this Google Fiber is really used for. Thanks, Virginia.
No problem.
So now you've seen all the compute and networking horsepower required to run your workloads in the cloud. Let's take a look at where your data is safely and securely stored. Let's go.
We have another 4 minutes. I want you to listen. I'll be away from my desk. I'll be back.
Querying terabytes of data on BigQuery or storing petabytes in Google Cloud Storage, all of your data needs to be stored on a physical device. Our data center infrastructure allows us to access our storage quickly and securely. At our scale, we need to handle hard drive and SSD failure on a daily basis. While your data is replicated and safe, we need to destroy or recycle used hard drives so no one can access your data. From the time a disk is removed from a server to the time it's decommissioned, we maintain a very strict chain of custody. The disks are completely wiped and then destroyed in a huge shredder. Let's go shred some hard drives. We've looked at a lot of the hardware that runs in our data centers, but it doesn't end there. We need to cool and power our infrastructure in an environmentally sustainable and reliable way. Let's take a look at how we cool our servers. Welcome to the mechanical equipment room. Looks pretty cool, doesn't it? Oh, hey, it's Brian, one of our data center facilities technicians. Hey, Brian. Brian, can you tell us a little bit more about this room?
Sure, well, this is a cooling plant for one of the data centers that we have on site. So a lot of heat is generated on the server floor, and that all has to be removed. And that starts right here in the cooling plant. So it's basically two loops. We have the condenser water loop, and we have the process water loop. The process water loop are these blue and red pipes over here. So they take the heat off the server floor, and they transfer it to these heat exchangers here. The condenser water loop are these green and yellow pipes here. They take the cold water from the basin underneath us, they transfer it to these heat exchangers here, and they send it up to the cooling towers up on the roof.
I noticed our pipes are Google colors. It's pretty cool. So how efficient is our data center?
Well, Google has some of the most efficient data centers in the world. In fact, when we started reporting our power usage effectiveness, or our PUE, in 2008, most other data centers were around 100% overhead. At that point in time, Google was 20% overhead, but since then, we reduced it to just 12%. And that even includes our cafeterias.
Whoa, that is so low. Also, what's this big green machine for?
Oh, well, this is a chiller. We very rarely use them, but it helps keep the process water temperature in the desired temperature range when it gets really hot outside, basically helping the cooling tower do its job. In some of our newer data centers, they have no chillers at all.
I love how our new data centers are even more efficient. By the way, can we go up and take a look at a cooling tower?
Sure, let's go.
Wow, what a view up here.
So Sandeep, this is a cooling tower. It uses evaporation to rapidly cool the water from the condenser loop and sends it back down to the basin. You could say we're making actual clouds with the cloud.
Clouds making actual clouds. Welcome to Google. So Brian, how do we power the cloud?
Well, that all starts at Google's power substation. Let's go take a look. So this is the Google-owned power substation. This is where the high voltage power enters the site, it's reduced, and then sent to multiple power distribution centers such as this one right here.
What happens if a power distribution center loses power?
If it loses power, we have multiple generator and utility backup sources available to maintain power to those servers.
And where does all the power come from?
It actually comes from multiple hydroelectric power plants that are nearby.
I love how Google uses reliable green energy whenever possible.
We are 100% carbon neutral, actually.
That's pretty cool. You know, it seems like Google builds reliability from the ground up, from the power and cooling all the way to the software systems that manage our fleet. Thanks for showing me around, Brian.
No problem. Have a great day.
Thank you for joining me on this special behind-the-scenes tour. Please check out cloud.google.com to learn how you can build what's next.
A data center is the brains of the internet.
I'm back. Hope you all can hear me.
Yeah, Bhaskar.
So now you have some clue, like the layers of security which you can see on physical data centers, and additionally you see how they protect the data in case of decommissioning any specific hardware, especially on a hard disk. They'll never ever give it for any e-waste companies as such. They'll crash and they'll use those resources within an organization. And you would have seen about energy and power cooling, how they recycle it. And Google is like working out towards more on renewable energies. In some years, you see everything dependent on natural resources like wind power, solar, and so on. Yeah, so that's just to give a workaround about how exactly a data center would look like. And you'd have seen that one single building, one single cluster, right? And all the servers are integrated together. And if you ask me which hypervisor is used in the backend, all cloud vendors do use their own I mean, they have dedicated Hyper-V versions. For an example, Google Cloud uses Linux hypervisor, Linux KVM, and AWS uses Citrix Zen server, and Microsoft uses Hyper-V. Okay. Yeah. So anybody, any doubts on understanding the advantages of cloud and the characteristics of cloud? All good?
Yeah.
Okay. Moving on to deployment model. Yeah. So let's take your fascinate about exploring cloud, and you would like to kick started. Where can I start? The answer is we have 3 public cloud organizations like Amazon, Microsoft Azure, AWS Azure, and Google Cloud. You can get started. And additionally, if you would like to set up your own private cloud in your company, let's take you have already invested a huge amount on physical hardware. See, for an example, IBM hold 10,000 plus servers. Okay, already they have invested. Now I don't want to move to cloud. I may move to cloud, but it not immediately. As of now, I want to save cost to the company. Okay, in that case, we have alternative to public cloud. We have something called OpenStack, where it is available it's available as an open source code, and you can go and download this application and you can deploy it on Linux operating system. Currently, Linux like Red Hat, CentOS, Ubuntu are supported with OpenStack, where you can deploy this application, and then in the backend it would be connected to one Linux based KVM, and you can manage your resources. Same thing here, Azure do have Azure Stack, and VMware have their own product called vCloud Director, where you can set up your own private cloud environment in your organization. And the third one is hybrid cloud, where if you would like to make use of more than one cloud, example AWS and Azure combination, or GCP and Azure, or GCP and AWS, yeah, or OpenStack and GCP, any of these combinations. If you'd like to enable, then we call it as an hybrid. More than one cloud, it's called hybrid.
What
This
about
may be
multi
needed.
products? My understanding.
One moment. I'll let me finish up this. So in future, people may stick to a hybrid model. The reason is cost. Cost is one of the biggest factor, and I'll also discuss who is expensive and who is less expensive. So if you see Microsoft Azure, they are cheapest in Windows Server, costing, and MS SQL. This is for Azure. For AWS, they are cheapest in Linux. Any Linux OS you deploy, they are the cheapest. And if you ask me, GCP, Google Cloud, they are cheapest in data engineering. For an example, you can speak about cloud storage. We call it as an object storage. And also we call it as data lake. Cloud storage is also called data lake. Data warehousing. Analytics. Can you keep yourself on mute? I'm hearing background noises. We want you to keep yourself on mute. I'm hearing background noise. Yeah. So each cloud vendor has got their own pros and cons. But think about an organization who is much concerned about optimizing the cost. In that case, they would be spread the services across multiple platforms. And then ultimately, your application or your client should access your resources. Okay, and it doesn't mean that that has to be deployed everything on a single cloud. They can also spread like an hybrid environment, okay, based on comfortability and the partner commitments. We have something called partner level agreements, where if you are a long time partner, cloud vendors do provide some discounts. Okay, there are numerous factors defines the costing. Okay, and one of the factor is if you are a startup company and you would like to save cost on these resources, then based on your nature of business, you can adapt to these services to save cost. All right, anybody, any question? Somebody had a question actually, so you can shoot your question now.
No, on what basis or on what requirement we will be going for hybrid cloud, Bhaskar? Because see, now I have a requirement already. I selected the cloud partner. Okay, I have to go with the Google or I have to go with the AWS. Now, what is the purpose of going with other cloud vendor to go for hybrid model?
As I mentioned,
Is it
right,
something?
this is the only factor.
Only the cost?
Only the cost. If you ask me as an outsider,
Okay,
for me,
so
this is the key thing for me. I want to save a cost. Where I found that this vendor is giving me a cheaper cost, I'll go with them for only those specific services.
okay, see, Bhaskar, in our real scenario, our client has actually decided to go with GCP, but our client is having their own data centers. Okay, so what will happen to the data centers now?
Good question. So we'll enable something called site-to-site VPN. See, what you will do in cloud, let's take this is on-prem.
On-premises, yeah.
And this is cloud.
Cloud, yeah.
What you will do in cloud, again, you build a VM, right? VM is here. And in on-prem, you have a VMware VM. VM should communicate with another VM. Do you agree? We'll enable site-to-site VPN. We have something called Cloud VPN. We'll enable VPN across both the platforms. That's all. So that it will interact like in private communication. For an example, on-prem, I have a virtual machine with this IP 192.168.0.4, and I want to communicate in cloud. In cloud, I have my own CIDR range, which I can set up in 3 private IP ranges, including 192 series. I'll set up like this 192.168.0.10. So it will communicate.
Actually, I think his question was, though we have a big setup like a data center on premise, why client decides to go for cloud?
Why client decides to go for cloud? Okay.
Yeah.
Point number 1. Earlier I discussed this could be a reason of OPEX. You want to save cost on operational expenses. Okay. So let's take my client have a old hardware. Let's say he purchased Dell PowerEdge BL series. This is 10 years old hardware and it's end of life, no parts is available, and I don't want to invest on this hardware. I want to decommission it. To compensate the computing power, I'll go to cloud. Additionally, I have licensing.
So slowly, okay, once everything is moved to cloud, so the data center will be decommissioned.
Absolutely.
Okay.
The reason is pretty simple and straightforward. Ultimately, to run my business, either I need resources from my local data center or a cloud. Anyhow, I'll end up in paying operational expenses. Every month I have to pay to somebody. Instead of paying to the old hardware with the high operational expenses, I'll simply go and pay only for the resources which I am running in cloud.
Okay.
Correct?
Okay.
Yeah.
So, okay, this whole process actually, how long it will take actually? So now my meeting is going to start from Jan, okay? So assume that we have 10,000+ servers. Okay. So based on your experience actually, because we are new to cloud and we don't know how long it's going to take, but based on your experience actually, can you tell us how it works actually, the whole process is going to work?
Yeah, definitely. So we have something called I'll put it in. We have a plan actually. We call it as start point. Workloads, migration types, assess, plan, deploy, and optimize. See, I have a different method of approaching towards migration, right? First of all, I should see where my workload is running, whether it is running or on-prem, cloud or on-prem. So let's say it is running on-prem. Workload, what kind of workload it is, whether it is an application based or virtual machine or an DB or an data, right? I have to segregate, and then I have to choose migration type. There are different migration types are available. We call it as lift and shift, refactoring, redesigning. And then in assess scale, we have something called learn, lead, scale, and secure, and then plan, deploy, and optimize. Finally, we migrate it and then optimize it. If you ask me, I have 10,000 servers, how long it will take, it depends on you. Like what you want to move first, whether you want to move to test, dev, production, or management service. So you have to segregate which one you have to move first, which one is very critical to your business, right? That you can plan it last. Let's take, you are very new user, right? I don't want to move your critical machines right away to cloud. Instead, what do you do? First you plan for testing machines. So what you will do, you will plan over 6 months, for an example, for this migration. The 6 months will teach you what are the limitations are available within Google Cloud. Okay, and if there is any migration challenges, you will make a note. You will define a proper change management documentations. Correct. You'll interact with multiple teams, get approvals, and you plan on the cost, and you work on connectivities between on-prem and cloud. Correct. So there are numerous factors to define, sir.
Okay.
Sarathi, if you look into our customer roadmap, right, they have a plan to complete before 2025.
Yeah. So another question, Bhaskar. Now, cloud is offering multiple services, like we know, infrastructure as service, PaaS, and SaaS. So now, how do I choose actually what is the service I have to go with? So the customer will decide, or will get a guidance from the vendor.
No. I'll tell you now. Okay, I'll tell you how this works. See, it depends. Again, you have to put it across your mapping, like start point and workloads. Let's take, I want to save costing on PaaS service. For PaaS, there are 3 options are available. One is virtual machine based deployment. Another one is serverless computing. We call it as an app engine. And the third one is called containerization. Okay, so we have 3 options for deploying an application itself. Okay, so most preferable option is putting into a containerization, where you create a container image, put it into a container engine, and then this container engine is managed by a container orchestration. So you see, there are different paces. Yeah, there are different paces, sir. Okay. So here I'm giving an overall and high-end overview to you. That, so you asked me a question like, how can I choose all these options? Okay, the thing is, wherever your workload is more, let's say your nature of business is completely an app-based company. Okay, then I would request you to go for containerized deployment. Understood? And you have an organization who do have an environment, but they won't do much with the application. They use it only within an organization. Let's take, in that case, they'll go with an infra. In that case, they deploy as a virtual machine. Okay. Yeah, and you can say that I have a company like a search engine, like I have like MSN or any other search engines, or Suleka or Monster, Naukri based search engines, where clients need to search databases. In that case, I'll design a data engineering based solution, where I would be needed something like a cloud spanner, where we call it as a distributed SQL database, which spread across multiple zones. Okay, or I'll go with the cloud SQL, where I customize my own database like MySQL, Postgres, and then create my own DBs and import from on-prem to cloud. Right. So here you have multiple options. It is like this, sir. So one liner, it's like this. So you are here in Bengaluru. You need to move to Delhi. So you have multiple transport options where you will take a train, you will take a bus, you will take your bullet, or take a flight. Each are mode of transports, but to reach faster you will take flight, correct? Because I'm an IT employee, my company offers me flight charges, I'll go in this. Just think about a person, a mason who don't able, you won't be in a position to offer for a flight, you'll choose a train, correct? Same thing here, we have all options are available from lower range to an higher range. So here you have to choose like what is expected out of it, and whether I have a budget or not, and what is my nature of business, and what kind of company is mine, whether I am in data based company or an application based company or an internal organization with just an virtual machines to run on. Okay. Yeah,
So everything will be decided based on the cost.
definitely, sir. What I'll do is I'll halt your questions. We can take a 20 minutes break, and then post break we can continue. Is that fine with you, all of you?
Yep.
Yeah, let me.
So now it's 3:30.
Yeah. We'll be resuming back at 3:51.
3:51, yeah.
And yeah, kindly